Hi everybody, we're moving on to learning targets 7 and 8, which have to do with circles on the coordinate grid. So let's just remember what we have here. We have a circle, its center, and then we have the diameter and then the radius. So just wanted to remind you of all of those vocabulary words real quick. And again, the radius is all the way around the circle. So if we put this on a coordinate grid, that's what we're going to be talking about. Anytime you have a circle on a coordinate grid, your center is going to be substituted in for h and k. Notice this looks an awful lot like the distance formula. That's because a circle is essentially a fixed distance around the center, which is the radius. So hk again is always the center point, so when you substitute it in, it's going to look like the opposite, because if it's a positive value minus a positive, it'll look like a negative. If it's a negative minus a negative is a positive, so it'll look like a positive. And then again, that radius goes all the way around. So this x and y are all the points around the circle that fit. So that's what the x and y are. They don't go, you don't substitute in for those. Again, you have that distance. So essentially you're saying like this value over this value squared. It's Pythagorean theorem, right? Is the radius squared? That's where this comes from. So whatever your radius is goes in and is squared. So let's use it real quick. We have the equation of a circle with center 1, 3 and a radius of 3. So we just substitute the values in. So you get x minus 1 because h goes in for the x value of the center, plus y minus 3 because 3 goes in for the k value of the center. And then your radius is 3. 3 squared is 9. Moving on to number 2. We substitute the values in. When you substitute negative 4 in, again, that changes to a plus 4. You don't have to show that step. I'm just showing you in the video so you realize it's minus a negative, so it turns into a positive. You are not given the equation of the circle, so you do need to be comfortable with this. So now, from a graph, I still need those two pieces of information. I need to know what the center and the radius are. So if I find my center, I go to negative 2, positive 4, so there's my center. And my radius, I just count from the center to the outside of the circle. So I get 4. And then I plug it into the equation. Doing it again, 2, negative 4 this time. 2, negative 4 with a radius of 2. I plug that information in. So it's all about the center and radius with the circle equation. That's what's going in. Now, can you tell me what the center and radius are from looking at the equation? So if I look at this equation, I see that my h and k values are 1 and 2. I knew that they were positive 1 and positive 2 because, again, it's going to look the opposite. And then it's always this radius squared, so I would take the square root of 4, which is 2. In algebra, the square root of 4, you always talked about plus or minus 2. In geometry, we can't have a negative radius. Distances aren't negative, so we just take the positive value of that square root. In number 6, we would have 4 and negative 3. Again, if you had substituted a negative 3 in, that's what would have given you that positive value. And the square root of 9 is 3. Keeping it going, we have negative 2, negative 4. Again, the opposite signs. And the square root of 16 is 4. In number 8, it's negative 1, positive 7. Square root of 25 is 5. So can you graph this circle? Well, let's look. I need, again, my center and my radius. So my center is at 0, 5. My radius is 5 because the square root of 25 is 5. It's always about these two pieces of information. So I plot 0, 5 as my center on my graph. And then from there, I count up 5, to the right 5, left 5, down 5, and I make my circle. Pretty. All right, that is it. Have a wonderful day, and I will see you in class.